It's time for Pure
Performance. Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello, everybody, and welcome to yet another episode of Pure Performance. We've got a rowdy crowd today, Andy. How are you today?
I'm very good, but I'm still sad and shocked after the event from last Sunday night. I know it's not a spoiler alert because until this airs, it's going to be later anyway, but they have a dragon now.
Right. and to point out there, I did want to bring up your theory because we'll either find out in the next episode, in which case, again, this is going to be airing way later, or it'll be maybe next season we'll find out, which in this case it won't be a spoiler. But since you brought it up, let's put it out there. The theory about Cersei's pregnancy.
I don't think she's pregnant. I think she's just playing this card to make sure that Jaime is really, supporting her and not going with the brother, supporting him with his ideas. And I think telling him that she's pregnant again from him just strengthens the allegiance. But I think she's faking it.
Yes, and as our guest, who we'll introduce in a moment, who we just found out comes from your town, right?
Yeah.
And you had some of his relatives in your school instruction, so that's really awesome.
His granddad was the principal of my school. Yeah.
Right, but he pointed out too in this conversation that the witch had only talked about 3 children, so that kind of helps solidify this idea. Anyway, who knows when we'll find out about this? This might be old news, it might not be, but anyway, Andy.
Yeah.
Who do we have on the show today?
So today we have Philipp, who besides being a fan of Game of Thrones, is also extremely well versed in Java. So Philipp is actually a colleague of us working out of our Linz lab. But really, to be honest with you, I really got to know Philipp and met him for real the first time at Dev1, which is a conference that we hosted this year in Linz. It was a DevOps conference from developers for developers. And Philipp gave a talk on what's happening in the Java world, especially on Java 9. And I thought it would be great to have him on the show because he sits at the source when it comes to what's happening in the Java world. And so without further ado, Philipp, welcome to the show. Please tell the audience a little bit more about yourself, and then let's jump right into the topic about Java 9 and what people need to know about it, especially around performance, around monitoring.
So hello from my side also. I've recently joined the Dynatrace team about a few months ago. I've been working before with the Dynatrace collaboration at the University of Linz. So I've been in touch with Dynatrace for a long time actually, but I've just recently started working there. Before that, I've just recently completed my PhD in performance monitoring, especially in memory performance monitoring. And I've been doing a lot of teaching in the area of performance monitoring and compiler construction and just programming, Java programming in general.
So, can you just fill us in the collaboration between the university and Dynatrace? So there's a lab at the university that is focusing on Java compiler, and then what's going on there?
Yes, there is a lab. It's called the Christian Doppler Laboratory, named after the famous physicist. Which is partly funded by Dynatrace, and we have done a lot of GC and memory optimization and performance analysis in that lab, and general data analysis in the area of both memory and CPU times and locking analysis. And my area of expertise was memory in that lab.
I had no idea that existed.
See?
That's awesome.
See, the lab of memory in general.
So, sorry for that laugh, as I like that little side punch here on the memory. No, I think it's cool, right? And so now Java 9. And so you presented, if people want to watch your presentation, they can go to devone.at. this is the conference page, and there's all the presentations listed, including for your session also the video. So you can check out the video of the full presentation. But from the highlights perspective, so your highlights, when you talk with people about Java 9, what is coming, what is finally coming, because I remember when you did the presentation in early June, I believe it was, not everything was really clear from the timeline of Java 9, but now we have the details. So fill us in, what's happening and what's important to know.
Well, whenever somebody asks me about Java 9 or somebody mentions Java 9, it's always talking about Jigsaw, which is the new module system in Java 9. So in Java 9, the developer can now split or package his classes in modules. And for every module, the developer can specify what packages the developer wants to export. So what packages are visible to users of that module, what other modules are required, even in what versions they are required, and also all other packages within that module that are not explicitly exported are automatically hidden and cannot be used by other modules. So it's also a kind of a visibility thing going on there.
Cool. And I remember when you talked about this at Dev1, there was still a lot of limbo around the project Jigsaw, right? That's been solved.
Yeah, it changed a lot in the last few weeks or months probably, because the Oracle wanted to do a very aggressive, to use this very aggressively. So, for example, per default, all the internal packages from the JDK were hidden. Of course, the JDK has been modularized also. So, for example, there's the Java base module containing all the core Java classes, like everything that is in Java Lang and Java Util and so on. And there are also other modules like Java RMI, which then contains all the RMI stuff, and Java SQL, which contains all the SQL stuff and so on. And there are a lot of packages that have always been in the JDK. And since they have been there, they have been used, but they have never been really part of the spec. So, and these internal packages, of course, are now internal packages in these modules and cannot be accessed anymore. So every library or application that used those internal packages was broken at that point because the classes could not be resolved anymore. And they now kind of went back a little and said, well, they can be used with Java 9. So even if you hide a package, it can still be resolved. But you get a big fat warning. It's even called a loud warning in the VM. So no matter what you do, you cannot turn this off. When you access such a class, you get the warning to standard error, and you cannot turn this off. And this warning is pretty aggressive. It tells that you should immediately contact the vendor of this certain class because it uses an internal API, and it should not. And so this kind of they made it a little weaker, this check, and the plan is that with Java 10, this check is reintroduced, and then you cannot access it really. So the people have a little more time to migrate to the module system and to get their stuff up and running again without those internal classes.
Mm-hmm. And so what does this mean from a developer perspective? I can modularize my code. I can say what I want to expose, what not to expose. Does this also mean class loading is changing, obviously, because it has to be enforced somewhere? And does this have a performance implication?
From the performance perspective, it pretty much stays the same because the class loading is not so much changed at runtime. At runtime, the JDK doesn't think of a module as a single entity, but it's more like every class loader still loads a specific class, or every class is loaded by a specific class loader. And but additionally now, Java 9 associates a module with a class. And when somebody accesses or some class accesses another class, an additional module check is performed, whether they are from the same module or whether this module has, or the using module has access to the used module. So this is only during class resolution, a few additional checks which are not really that critical in terms of performance. But the class loading has changed a little at the JDK level. For example, until now, up to Java 8, there have been 3 out-of-the-box class loaders, which are the Bootstrap class loader, the extension class loader, and system class loader. And basically, the Bootstrap class loader loaded all the JDK. Then the extension class loader did some magic nobody really understands. And then there was the system class loader that loaded your application or starts loading your application. And now there's this new concept of a platform class loader. This is something actually new that has changed since my talk. The platform class loader now guarantees to have access to all JDK classes. But whether they are actually loaded by the platform class loader or by some other class loader is not defined. So there might still be some JDK modules that are loaded by the Bootstrap class loader, some might be loaded by the platform class loader, or some might be loaded by some class loader in between. But just the platform class loader guarantees you that you can resolve every JDK class via this class loader.
And again, just to my question, I mean, class loaders have always been a challenge for, always on the one side, developers, but also for tool vendors, especially if you do, bytecode instrumentation. Having multiple class loaders was sometimes a challenge to make sure that we are instrumenting all the right things and we actually get hooked into the class. So is there anything that has changed for tool vendors now, or should that be transparent?
If you have, let's put it like this. If you have implemented your application according to the spec and have not done some magic in class loading, like circumventing the parent delegation or something, like some popular APIs do, then you should not have a problem. But of course, if you rely on specific classes to be loaded by a specific class loader, you might be running into problems. For example, we in Dynatrace now have the problem supporting Java 9 that the JDK is now some JDK modules are loaded by the Bootstrap class loader and some are loaded by the platform class loader. So not everything that is loaded by the Bootstrap class loader can access the entire JDK because it might not be loaded by the Bootstrap class loader.
Okay, yeah.
So in the Dynatrace case, for example, we inject our agent to the Bootstrap class loader. Or we have so until now. And from there, we can't access the entire JDK anymore, which is, well, for example, SQL and RMI are loaded by the platform class loader. And we would very, very much like to access those, of course. Yeah. So we have to do some magic there to still get all the things we want.
Yeah. Cool. And that's, hopefully, and as you said, we're doing some magic there or something different. And that's going to be a challenge for other tool vendors as well. Cool. All right. So you talked about Jigsaw. I understand that. You talked about the class loading. Anything on these topics that we missed? Anything else we should mention?
Well, the big things we already mentioned is those are on the one hand, the class loading is a little different, and on the other hand, it's that some packages are now hidden, and you can still access them with Java 9, but at the latest Java 10, you will have significant problems whenever you use these classes or even use libraries that use those classes, of course, because they will break.
Yeah, and so that means for people that monitor these applications and they want to make sure that they are according to standard in Java 9, watch out for the error logs because there will be these loud warnings, as you called them. That's something to watch out for.
And what you can also do is you can even enable the restricted mode in Java 9 already. It's just a regular command line flag where you can enforce those checks to really throw exceptions. And then you will see very fast whether something breaks.
Cool. And I assume this option is well documented, so people that want to check it out and look it up, they just go to the Java 9 doc. Yeah.
Yes, exactly. So, and you can even see it by just calling -help on the command line tool.
Yeah. Cool. Other topics. I mean, I'm looking at your presentation right now, and one thing that strikes, I mean, there's several things in your presentation that I liked a lot. I'm just picking one now, which is that the change, the G1 as a default garbage collector.
Yes.
Right? I mean,
That's
and
the one I was thinking
memory
about too.
yeah, because memory is your field of expertise. So what do we need to know there?
Well, G1 has been introduced, I think, with Java 7 update something. And it's now, until now, the entire JDK 8 or up to JDK 8, the parallel old GC was the default collector. And now it switched to G1. So you still have all garbage collectors available, but if you don't specify one explicitly, the default one will change, or is changed with Java 9. And G1 has one big difference compared to the others. It's partly concurrent, meaning it tries to collect while your application is still active, or at least do a lot of work while the application is running. And also it can collect very large heaps efficiently. So this is one step towards making Java more feasible for really big heaps. And we are talking 100 gigabytes and above, because other garbage collectors just can't be bothered with this kind of heap. They just take forever collecting it. And the G1 can kind of guess what region contains a lot of garbage and then just collect that region. So the runtime of the garbage collector is not dependent in any way on the actual heap size, which is the case for all other garbage collectors.
Now, the question I had with the garbage collection, I read, a teeny little bit about this before we started, and it seemed like the G1 is someone was alluding to the idea that G1 might be more beneficial in the larger heaps. Does that mean G1 is not, like, if you're running microservices and you have a very small heap, is G1 still going to give you benefit over the old parallel, or is that the kind of time when developers should say to themselves, hey, I should manually switch back to parallel? Or is G1, do you think G1 is going to have performance gains for any size heap?
Well, it's difficult to predict without having the actual allocation and memory usage profile of a specific application. Mm-hmm. But I would guess that with very small heaps, it would not make much difference, because the G1 really, for small heaps, it's just doing some things for nothing, but it should not have any negative impact, at least.
Okay. It's
just like using the old collector from performance-wise.
And just let me ask you one more question now. When we talked a lot about memory diagnostics in the past, and we have a lot of material online about how to do memory diagnostics in Java, which metrics to look at. What changes from a monitoring perspective when we look at G1 metrics? What are the things to watch out for to understand whether you actually have a memory issue or not? Are there any new metrics, any new measures, anything else to watch for?
Well, I don't know whether it's really a new metric, but the G1 has a completely different paradigm of working and dealing with garbage. So, for example, the old garbage collector, the parallel old GC, which is still very well supported in Java 9, if you need it, just waits until your heap is full, and then it tries to collect as efficient as possible. For the G1, you can specify a pause limit, meaning you can, for example, specify my application shall not pause for more than 1 second at a time. And of course, it's kind of a soft constraint, so you cannot absolutely guarantee it, because Java does not run in a real-time environment. But it is usually very good at achieving this goal. So it's not so much a difference it makes not so much difference about what metrics to look at, but probably more with how to tune it and how to really configure it, because this can make a lot of difference. And there is another thing you might want to look out for, because the parallel old GC and all other GCs have two types of collections. They have minor collections and major collections, which is basically just a bad word for partial and full GCs. Minor collection usually means a part of the heap is collected, and minor collections are usually very fast, but they can only collect a part of the heap. And major collection is usually very slow and means the entire heap is collected. And what you observe with the parallel GC is you have a lot of minor GCs, and then at some point you have one major GC. And then you have, again, a lot of minor GCs until you have one major again. The G1 only has minor GCs, usually, which means it always, even if it collects the old generation, it always just collects a part of the heap, never the entire heap, which makes it very efficient for big heaps, because it just, when you run out of memory, it selects a heap region which it estimates contains a lot of garbage, and then it collects that region, no matter whether it's old space or new space or survivor spaces or whatever. And the G1 also has a major collection, but this is an absolute emergency for the G1 GC. So it usually only needs to do major collections when everything is running completely out of memory or there's something really weird going on in your heap. So this might be something to look out for if you're using the G1 and you see major collections in your log, then something really bad is going on.
Mm-hmm. Hey, then I have a question to this. So if collections happen, whether it's minor or major, does the JVM block current executing threads in both cases, or is this just true for major GCs?
For the parallel old GC, both minor and major are what we call stop the world garbage collections, meaning all application threads are suspended, then the garbage collection is executed, and then all application threads are resumed again. For the G1, the major is also stop the world because it's really an emergency action. So it really needs the application to stop doing whatever it's doing and tries to get itself together again. For minor GCs, part of the work for the minor GCs are done concurrently, meaning the application is not stopped. So this is specifically the marking phase. So what's usually how a G1 collection will work is the G1 will decide to do a garbage collection, then the VM will be halted, so all application threads will be stopped for a very short time, just to gather some statistics and start the garbage collection. And then the application threads are immediately resumed, and then objects are marked, or live objects are marked, and a lot of the garbage collection work is actually done. And then at the end, it again needs a small pause to just to put it all together and finish the garbage collection. So instead of one big pause, you have two very small pauses. And in between, the application might be a little slower because there are garbage collections in the background trying to do their work.
And the reason why I'm asking this question is because when we do memory analytics and especially trying to figure out the impact of garbage collections on the actual running applications and transactions that are executed, in the Dynatrace world, we often ask people to go and look for the suspension time, which we report per transaction. So how long was this particular transaction suspended because of, for instance, a GC? And so the way you tell it to me now is we should see these numbers go down because the hold the world or stop the world is less common. But unless you have this, it's the end of the world almost, then you obviously have, then winter's not coming, but winter's here.
Exactly. The suspension times will probably go down, but you will still we probably have to think about it a little differently because we still have some impact from the garbage collector when it runs in the background because there are threads consuming CPU time.
Right. I was going to go there. That's going to make it a little more difficult, right? Because at least in the old way, at least at Dynatrace, we could see that CPU time was actually during the suspension. So we knew it was garbage collection. Whereas now we'd have to look for I guess, is it a case where we'd have to look for a suspension, then a spike in CPU, and then like another small suspension for those begin and end if we wanted to try to isolate whether or not that spike in CPU is related to memory or?
I don't know whether you really will see spikes because this depends on what the application is doing.
Right. But or a little uptick maybe, I guess.
But you will, the garbage collection logs already will show this very beautifully because you then see that the first pause is called an initial marking and the second pause is called the final marking, and you will see those with timestamps in the log, and we'll probably have to do some adjustments in Dynatrace to properly visualize that.
So for everybody who's finally gotten used to analyzing memory, Winter is coming.
Yeah, exactly. And Philip, is there? I assume there's already some material out there. I think you mentioned it earlier. If you want to read up on G1 optimization, G1 strategies, G1 analyzing G1 activity, there's material out there that we can point people to.
Yeah, there are a lot of just you need to Google it and you'll find a lot of web pages that show different optimization strategies, and they try to explain how to do it. Also, it's very easy to find is the original paper that suggested outlined the actual algorithm of the G1. And it's not so difficult to understand basically what it basically does. It's pretty easy. But it's a lot. I know the implementation of G1, and that's a completely different story, because there's a lot of very weird optimization and C++ magic going on in there to really get it perform.
Now, so thanks for that. That was a great segue or great overview of G1. Other parts in your presentation that you covered were, I think there's two interesting parts for me that I see here, and I want to go with the first one, which is the stack walking API. The reason why this is kind of interesting for me is because I know we do a lot of stack analysis when we are capturing our auto sensor data. We're trying to get information about what's currently on the stack. So what is the stack walking API? Is this just a new API that was introduced, or is it just an extension to what we had before? And what is this all about?
Stack walking is a difficult operation in general in Java and in other technologies, because whenever you take a stack, it's difficult to know at what position the actual application is at, and you need to resolve the method properly. You need to resolve the calling stacks, stack frames, and so on. So it's not that easy to decode a stack trace. And this is why the VM usually uses save points to take stack traces. And a save point is basically just a location in the code or in the machine code that is defined by the VM automatically, and it just means the VM remembers and stores all the data and all the information it has about a specific point in the machine code. So whenever threads are at a save point, it can probably decode a stack because it knows how big the stack frame is and so on, and what values are in what registers and so on. And until now, taking stack traces meant forcing all threads into a save point. So you basically, when you wanted to take stack traces of all application threads, or even of one application thread, it meant that the entire VM had to run into a save point, meaning all applications had to reach a save point, and then you take the thread you want and you walk its stack while it's suspended, basically. And there have already been a few optimizations out there that when you request the stack of your own thread, meaning you request your own stack, you don't have to be at the save point, because the other threads really don't matter, and you already know your own state, or the thread knows its own state, so it can walk more easily. And this has been possible via the Java Virtual Machine tool interface for quite some time. But on the managed level, you always had to make this. You always had to go via exceptions. So, for example, you just create an exception object to get the stack trace out of it if you wanted to know your own stack trace. And now there's a very pretty API that actually lets you walk the stack. So it's called the Stack Walker, and you can, using delegates, you can specify how many stacks you want, whether you want to ignore some internal stack frames like that are generated from reflection or via some generated code and so on, and you can walk your own stack this way. So when you want to look at who is calling me, or make some security checks based on callers, or just print for debugging where you currently are, this new API is very efficient. And the second thing that is very expensive doing stack walks is the decoding the stack, meaning you need not just only be at the save point, you also need to decode every single stack frame, meaning finding out what method that actually is finding the parent and so on. And using this stack walking API, you can now specify beforehand how many frames should be decoded and what their properties should be. So when you just want to notice the caller, you only need to decode the caller. Via exceptions, when you go the way through exceptions, you always had to decode the entire stack, which if you have 100 stack frames on there, meaning you have to decode 100 stack frames just to access then the first element.
Yeah, and thanks for bringing that up. So what you just reminded me of, we did a blog series on the overhead of exceptions, and we saw a lot of examples from our customers that were using logging frameworks where either in a debug log mode or even general log modes, they were basically logging out the current exception stack or the current stack, and they were basically just doing what you said, creating an exception object. And this is not a problem if you are a developer on your local machine, but it becomes a problem if this actually ends up in a high load environment. Exactly. And I remember I have a couple of blog posts where 50% of the CPU is actually just running into creating these exception objects. And not only that, because in the end, somebody needs to garbage collect all of the information as well. So there's a lot of overhead. But so this seems like a great way to make this much more efficient. So the stack walking API, which has been introduced with Java 9, that's cool.
We have even observed similar behavior in well-known Java benchmarks. We have found a benchmark that actually tries to read some files, and they have implemented their own file stream API or input stream API. And instead of returning a dedicated end of file token when the end of the file was reached, they threw an end of file exception and just kind of read in an endless loop until an end of file exception was thrown. And this resulted actually in more than half of all the objects being allocated just being exceptions and stack trace information.
Yeah. Cool. So stack walking API. Anything else to that, or that we missed?
I think the stack walking API, we kind of covered that. It's not very difficult, but it's, I think, a huge improvement if you want to implement those things.
So this will be a shout out for log providers, log framework providers, or however else you use stack traces right now. So look at this. The other area that I wanted to touch upon is you talked a lot about compiler and how Java level compilers changed, and yes. I assume that also has maybe an impact on compilation times, but also maybe performance. Maybe there's some improvements on the code that gets generated in terms of performance.
There are two big changes, or two things that are introduced in Java 9 that I'm not entirely sure of how much they will be used, those features, but they are definitely interesting. The first one is the JVM CI, which stands for Java Virtual Machine Compiler Interface, meaning you can now write your own JIT compiler, not ahead of time compiler, but JIT compiler in Java, running inside your own VM. And also in turn cheating itself. So until now in Hotspot you had you started out interpreting code, and then at some point the client compiler kicked in, generating some kind of good machine code, and then at some point the server compiler kicked in and generated very highly optimized code. And now you can also have an additional tier in there, which can just be your own compiler. So, and there are compilers out there, for example, Graal, which is a research project also by at the University of Linz. That is a JIT compiler that is completely implemented in Java, and they run inside your VM and then also JIT themselves, which is pretty interesting. So we might at some point run into applications with compiled code that is just. Or we might run into situations where companies have their own JIT compilers for specific situations. I don't think this feature will be used very widely. I kind of think this is more like an internal Oracle feature, because they really are tired of maintaining all this complicated C++ code in which those JITs are currently implemented, and it's very difficult to try new things because it's just such a big thing, a JIT compiler, and supporting an interface where you can implement the JIT compiler in Java and also maintain it in Java makes it a lot easier, because Java, of course, is a lot easier to develop and in terms of bugs and things you need to take care of compared to C++. And so this is more, I think, a feature mainly for researchers and Oracle itself, but it's still a very interesting feature, I think.
Yeah, definitely. And you mentioned Graal, so Graal, one of the projects that you've been working on. Cool.
It's just a project of the University of Linz. I have not been working on that one, but it's still very interesting.
Cool. And now from there, so you talked about this aspect of what has changed in the compiler world, but then there's another thing. If I look at your slides, which is the ahead of time compilation, I guess. Exactly.
So the Java VM now supports ahead of time compilation, which there is already an ahead of time compilation, which is called Java C, right? You have a Java source file or maybe a Scala source file or whatever, and you generate bytecode via Java C. And then at some point, the VM takes a bytecode when it needs to execute a class, and then at some point might translate that bytecode to machine code. And now you can specify a precompiled native library for the JIT, so that the JIT doesn't have to compile it at runtime, and the VM doesn't have to start interpreting classes and interpreting bytecode. It can immediately take the precompiled library. So you can just take a class file and precompile it to a shared object or DLL, whatever operating system you're running on, and then provide that library to the VM. And then it will take this library as machine code and execute it as such. There are a few restrictions. For example, you need to already specify all command line flags the VM will run in, because, for example, what garbage collector you use has a significant impact on the generated machine code. So you already have to specify what garbage collector this machine code should be generated for. And if the supplied library does not match, the VM can still fall back to just interpreting the class file and then JITing it itself. But for some specifically small applications that don't run very often, or not very long at least, where code or hot code might not be JITted, this might be an interesting way to speed up.
I remember this from the .NET world. Right? I think the .NET runtime had this feature where you could actually precompile your .NET intermediate code into machine code and then deploy it on that machine. And I think the main argument was definitely launch speed up time, or speeding up launch time of applications. Yeah. But does this also mean if you want to do monitoring of these apps, and obviously we get our monitoring agent in the JVM, which obviously modifies bytecode, would we work? Does it do monitoring tools that inject agents into an application? What would happen in this case?
Well, it would definitely work. The VM would just throw away the machine code, because at some point the VM has to detect that. Like monitoring, what monitoring tools do is they take the class file and instrument it, right? So they change the bytecode. And at that point, the bytecode does not match the precompiled library anymore. So what the VM would do is just throw away the library. The VM has a very graceful fallback where when it detects for some reason, whatever that reason may be, that the library just does not work, like it's compiled for a wrong option, this class is slightly different, or it has changed or somewhat, it just throws the library away and starts interpreting and JITting again. So in this case, we would just negate the monitoring tools would just negate the probable performance enhancements that come from that library. What would be more interesting is maybe even pre-compiling sensors into that code.
Yeah, that's what I thought too. It was cool, yeah.
But I don't know whether this is possible. It would be definitely very interesting. But it sounds like some big magic going on there.
Cool. Hey, I know we've already kind of crossed our, we try to keep it to 30 minutes, but it's very interesting what we discussed here. Is there anything else we should mention? I mean, we talked about a lot of different things. Anything else in Java 9?
Well, there are a lot of just small language things that are probably interesting for people that really program Java. I would suggest we just put on the slides online, probably with this podcast, and then people can look through a few of them. There are quite minor things, but a few nice things also. Just keep in mind that Java 9 has not been, there has not been a release candidate when this presentation was created, and it's still not released, right? So we have 28 days to go.
Right, it's September 21st, right?
Yes.
So I do want to point out, September 21st is the day that The Hobbit was originally published. And it's also, it's Bill Murray's birthday. And it is also Independence Day for Malta, which I'm supposedly have ancestors from. So it is an auspicious day for Java, but we'll see if they make the date, right? Is it pretty set, or do you think there might be, is there a chance of delay at this point, or are they...
I don't think so, because the original, it has been postponed because the community voted against it due to the Jigsaw version they had back then. But the second vote was unanimous. Was a unanimous okay. So there's no veto from the community. Okay. And I'm working a lot with the release candidate to get Dynatrace up and running for Java 9. So it looks stable. So I don't see any reason why it shouldn't be released.
Everyone using Java 9 can always think of Bill Murray then, and The Hobbit.
and the Independence Day at Malta.
Yes, well, there's a lot of other Independence Days. I just singled out Malta because my grandmother's supposedly from there.
Cool. Hey, Philip, anything else? The smaller changes? I mean, walking through your slide deck, there are some, I think it's also smaller changes. Well, there's the spin weight hints, the HTTP2 client. I guess these are what you consider smaller improvements.
Yes. What I find particularly interesting, there's now a tool called the J shell, which is basically an interactive shell where you can execute Java code.
Ah, okay.
This is a lot of languages already have that. I just think it's nice that now Java also has this feature. You can just type in arbitrary Java code and let it execute.
Yeah, and I assume that J shell is also fully, I mean, most of the IDEs out there, whether it's Eclipse or IntelliJ, they probably have their own little version of it, embedded like a view.
Probably, I don't know. Until now, the Java 9 support in IDEs is pretty poor. So in most IDEs, you can't even install a JDK 9 without crashing the IDE. So this is an interesting topic, how fast the IDEs will get it up and running.
Well, maybe we can encourage listeners, whether you are from an eIDE vendor or you just have time to extend other IDEs, because most IDEs have extension options, right? And you can just write your own extension and put it up on GitHub and then make others happy because they can use these cool features in their IDEs. Awesome.
I think the one supporting it the most was IntelliJ.
Yeah.
Works the best right now.
Yeah. All right. Hey, Philip, did we miss anything that people need to know about Java 9?
I don't think so. I think we have covered this, at least the most important things.
Yeah.
All right. Brian, how do we do the wrap up?
Well, I do want to add one more thing that happened on September 21st. Just because the title is so cool. I'm sure it was actually horrible because this was in 1380. So there was probably a lot of horrible blunt force deaths. But it is a Russian military day of honor for the victory over the Golden Horde, which just sounds really awesome to me, but I'm sure it was really horrible.
Is this another Game of Thrones reference?
No, this was the Golden. No, but this was 1380, a Russian military day. It just sounds cool, though. Anyhow, let's. Why don't you go ahead and give us sum up, Andy? We'll go on to our summer. Maybe should I get a summarator? Why don't we put it to the audience? Should we get a summarator sound effect for you? Or maybe, I don't know if we can use an Arnold clip.
Sure we can. We we ask for forgiveness later. We don't have permission.
Well, now we can.
Why not? But, let's do it.
Either way, yes. Andy, please go ahead and pull up your summarator.
So basically, kind of what I learned today is that Java 9 is finally almost there, September 21st, sharing that date with many other cool things that happen in the world. Thanks, Philipp, for giving us insight, especially what happened around G1 as the default garbage collector. You also told us about Project Jigsaw, which in Java 9 is not enforced, kind of like hard enforced, but soft enforced with error messages that are written out in case your application is accessing modules that are not to be accessed because they're kind of hidden away. So that means lesson learned for people that are testing Java 9 applications. Watch out for the error log and see if your application currently accesses any modules, any classes in modules that are not exposed, because in Java 10 you don't have the option anymore. Your application will just not work anymore. So we learn about that. We also learned about the class loaders and how that can be tricky, especially also for monitoring tools. That includes Dynatrace, where we're working on making sure we can actually instrument bytecode independent of which class loader is loading it. And then in the end, I think you enlightened us a lot about what's happening on the compiler side, being able to use your own Java-based JIT compiler. The project Graal, one of the projects that came out of the University of Linz, is using that. And we also learned about the ahead of time compilation, where you can already pre-compile Java code to the machine where you're going to run it, which will speed up launch time of applications. So there's a lot of cool stuff happening, and I know the Java community is a huge community, so I'm sure they will be leveraging the new features. It seems though that the IDE vendors have to get their game together and provide updates soon, because right now, based on what Philipp told us, there's still work to be done there. Philipp, thanks for this show. Thanks for the insights. I hope I didn't miss.
Thanks for having me.
Brian, final words? Any other references to other events that happened September 21st, or any other spoiler alerts from Game of Thrones?
That's about all I can contribute to this conversation, because as I'm listening to this, I realize, wow, there's so much about coding and developing that I just have no idea about. My background at Philipp, we've never met before. My background was performance testing and metrics and that kind of stuff. So when we start going into this level, it's way over my head, but it's amazing stuff, and it just really kind of reinforces the respect I have for developers who have to go into this kind of depth of technicality for all this stuff. And so hats off to all the developers who are going to especially have to deal with some of the changes that are coming up here. It doesn't sound like it's going to be the smoothest transition, but it's not going to be a break the world transition. But I'm sure there'll be a lot of road bumps along the way, and hopefully everyone can join together and share what they learn and figure out great new ways to leverage the features in Java 9. And Philipp, great to meet you. I didn't even know you were working for us, so that's even awesome. And a lot I learned today. So thanks for being on the show. It was wonderful. And that's all I've got, Andy. Philipp, any final things to the audience? Any appearances coming up?
Sorry?
Do you do any speaking engagements? Any final thoughts? Anything you want to put out there?
Not really in the next few months. I can always kind of make some advertisement. There's a lecture. I hold a lecture every semester about Java performance modeling benchmarking. So if you are at the University of Linz, you're invited to join.
Awesome. Cool. And Andy,
that's great.
Yeah. I was going to say, anything else on your side, Philipp? I didn't mean to cut you off there.
No, not really. Thank you for having me. It was fun.
Andy, this will be towards the end of September, early November, I think. Anything you want to promote?
I guess you meant end of September, early October.
Oh yeah.
I will be in Dublin for Quest for Quality, first week of October. So that would be great to meet people in case you are in Dublin. And then we have a couple of DevOps events coming up, DevOps Days in Philly, maybe also Nashville, and then at the end of October, I believe. No, that's later in November. It's AWS reInvent. So check it out. There is also a page on the community, on the Dynatrace community, where I keep all the events, or you just go to our website and search for events. We typically list these things. But Quest for Quality in Dublin is going to be something I'm looking forward to.
That's awesome. And I actually just did my first meetup last night at the Docker meetup in Denver. So thanks to them, this will be obviously a while back. I may be doing one with the Denver Java users group in early November, and the Docker meetup team, they're I guess family with the Denver DevOps group, and I might be presenting there. So just keep a lookout on my Twitter feed, I guess.
Yeah,
it's all local stuff, but hey, it's first time.
Yeah, it's the way you get started.
Yep. Excellent. All right. Well, thanks again, Philip. It was wonderful to have you on, and wonderful to go into this. Yeah, it's crazy stuff, but I'm sure for the people who work in this, it's not that as crazy. Thank you.
All right. Bye.